So in lesson 18.3, we're talking about how this climate change that now we have defined and talked about how we study it, the effects that it's having, which are pretty drastic. So that's what we're going to be talking about here. Um, so climate change has already had numerous impacts on the physical properties of our planet and organisms and ecosystems and on human well-being. That's what we're going to talk about today. It also predicts changes in these phenomena as well as impacts on wildlife, ecosystems, and society. So here's a diagram of what has been going on. So average surface temperatures have risen 0.89 degrees Celsius since 1900. By 2100, it will rise more than 1 to 3.7 degrees more. We are actually going to talk about all of these things in this lesson. So take a look at this. This is kind of a good overview. Also in your book in this lesson, it puts it into a table with more text. So the evidence for climate change is extensive. So there is, if people say there's no evidence for climate change, that is not true. They are just not looking in the right places, which is everywhere. So we have this thing called the International Intergovernmental Panel on Climate Change. IPCC is how we'll talk about it for the rest of the lesson. And it was established in 1988 by the United Nations to review and summarize all available data in climate studies for policymakers and the general public. So basically, there's tons and tons of research happening for climate change, and so the IPCC puts it all together, and it's a panel made up of policymakers and general public and scientists that are making decisions about these things. So in 2013 and 14, they released their fifth assessment report, which summarizes the trends in surface temperature, precipitation patterns, snow and ice cover, sea levels, storm intensity, and other factors. And it predicts future changes in these phenomena after considering a range of potential scenarios for future greenhouse gas emissions. It addresses impacts of climate disruptions on wildlife, ecosystems, and society, and it also discusses strategies for response. Okay, so now we're going to talk about all the things that have happened because of climate change, or what will continue to happen. So temperatures continue to rise. So the Earth's global temperatures are rising. The average surface temperatures, both land and ocean, have risen by about 1.1 degrees Celsius, which is 2 degrees Fahrenheit, in the past 100 years. And that might seem like not very much, but it has really big effects. So most of this increase has occurred since the 1970s. This is a graph showing the global average temperature. So it was much colder a long time ago, and now this is how it has changed since the decade. Okay, so how it has changed since the average from the whole 19th century. This line is the 19th century average. And most of it happened since 1970. Since 1995, we have experienced the 19 warmest years on record since we started recording 136 years ago. So obviously that statistic isn't super up to date to this year, but the 19 warmest years ever since we started recording. So if you were born after 1976, which I believe you all were, you have never lived through a year with average global temperatures lower than the average. So you've never lived through a blue year. And if you were born after 85, you've never even lived through a blue month. So every year and month have been warmer than the average from the 19th century. And in the US, temperatures in most areas have risen by more than 1 full degree Fahrenheit in the past 2 decades. I like that they changed that to Fahrenheit for us. So again, this might not seem like much, but it is exceedingly rapid change and enough to cause countless impacts. And this trend will continue because we are still emitting greenhouse gases, and the ones that are already in the atmosphere will continue to warm for decades and decades because they have a long residence time. At the end of the 20th century, the IPCC 21st century. At the end of the 21st century, the IPCC predicts global temperatures will be 1 to 3.7 degrees higher than today. So it's going to keep happening. And because of this, unusually hot days and heat waves will become more frequent. And then the future changes in temperature are predicted to vary from region to region. So the polar regions, for example, are expected to experience the most severe warming. That has a lot to do with different positive feedback loops we'll talk about later. But the North Pole, the Arctic regions are expected to have the most severe warming. That's a lot. That severe red is 7 to 9 degrees increase Celsius by 2100. So in addition to temperature changing, precipitation is changing. So a warmer atmosphere speeds evaporation and holds more water vapor, and precipitation has increased by 2% over the past century. So as air temperatures rise, then that warm air can hold more water, which we talked about, so there can be more water there, which would lead to more precipitation. Overall, some regions are receiving above average amounts of rain and snow while others are receiving less. So it's having differing effects across the globe. So we know that in the western US, droughts have become more frequent and severe, which has harmed agriculture and promoted wildlife. We're out of a drought now, but we were in a very bad season of drought for years and years. And in the eastern US, heavy rain events have increased, which has led to floods that kill dozens, leave thousands homeless, and inflict billions of dollars in damage. So on the eastern coast, they're having having a big increase in precipitation while we are having a decrease, especially over here. And so I just talked about big storms and heat waves and things like that. So extreme weather is becoming the new normal. We're just getting used to it. So the frequency of extreme weather events, droughts, floods, hurricanes, tornadoes, etc., has doubled in the United States since 1970. So the frequency of any of those crazy things has doubled since 1970. That's a lot and not a lot of time that we've even been in the United States, let alone how long humans have been on the earth. So for example, in the US in 2012, it was the hottest year ever recorded. There was a freakish heat wave in March, and then a severe summer drought. That's kind of where our really gnarly California drought started. And Superstorm Sandy on the East Coast inflicted $65 billion of damage along the Atlantic coast. And we'll talk about Sandy a little bit more later. So because of all this stuff, insurers have recorded a 50% increase in losses from extreme weather in South America, a doubling of these losses in Europe, and even higher rates across the rest of the world. So insurers are noticing this as well. So climate scientists say that although climate trends influence the probability of what the weather will be like on any given day, no single particular weather event can be attributed directly to climate change. So for example, we can't say that one storm or another storm or tornado or a drought is directly because of climate change, but we can definitely say that the frequency of them is because of climate change. And the analogy your book gives says that if you have a baseball player who's taking anabolic steroids and they increase their home runs like crazy, we can't say that any one home run is because of the fact they're on steroids, but the fact that their home run rates is definitely correlated to the use of steroids, if that makes sense. So there was a study done in 2012 that revealed a potential explanation for the increase in extreme weather. So warming has been the greatest in the Arctic, so up at the North Pole, and it has weakened the intensity of the northern hemisphere's polar jet stream. So remember, we have this typical jet stream, which is a weather pattern that moves, or it's an air current that moves weather systems west to east at a normal rate. It's a high altitude air current that blows east to west in a curving pattern that wanders north and south. So this is normal. Okay. However, the jet stream has slowed down. And as that happens, as it slows down because of the warming in the Arctic, as it slows down, it forms an atmospheric blocking pattern, which blocks the eastward movement of weather patterns. So basically, this causes all weather patterns to be held in place for longer periods of time. So this is a lot more drastic. So the weather patterns get caught around it. So for example, a rainy system that would normally move past a city in a day or two might be held in place for several days, which could lead to flooding, or a heat wave or a drought that may last 2 weeks instead of 2 days, which could result in drought and kill crops. The record-breaking heat in the eastern U.S. in 2012 came from the jet stream being stuck in place. It also led to a drought in Texas in 2011, 2012 wildfires in Colorado, and severe wintry weather in the eastern U.S. in 2014. So basically, this slows down because the Arctic is warming, and then it keeps the weather in place, creating much more severe weather than normal. So now we've talked about temperature and precipitation and extreme weather, and then another one is the melting of ice. So all along both poles there's glaciers, but they are melting as the temperatures are warming. So many tropical mountaintop glaciers have disappeared, and the few that remain are shrinking. 1 out of every 6 people worldwide lives in regions that depends on mountain meltwater as a source of fresh water. So basically there's these glaciers that are from mountains accumulating snow in the winter. And then when it gets warmer in the summer or in the spring, they melt and water rushes down through rivers and streams and provides people with running water. So if you've ever been in the mountains, probably in the US, but also in Europe, like around Switzerland, the water is freezing even if it's really hot out because it's glacial meltwater. And 1 out of every 6 people live in a region that depends on this meltwater, and it declines in summer weather. And between 1980 and 2015, the World Glacier Monitoring Service estimates that the world's glaciers, on average, each lost a thickness equivalent to nearly 19 meters in vertical height of water. So each glacier lost an average of 62 vertical feet of ice. That is a lot. In Glacier National Park in Montana, there were 150 glaciers originally there when it was founded, and now there's only 32 remaining. And so polar ice is melting really quickly, and with the entire West Antarctic, so South Pole, ice shelf potentially on its way to an unstoppable collapse. And if that glacier collapses, it would create a 3-meter rise in sea levels. 3 meters, almost 10 feet rise in sea level. So that is really, really not good. As the snow and ice melt, it creates a positive feedback loop that makes more snow and ice melt because so snow and ice are super reflective. If you've ever gone skiing or been outside in the snow on a sunny day, it's blinding because the white snow reflects light back up at you. So the earth is not absorbing the heat when it hits the snow, or not a lot of it. However, as that snow and ice melts, it reveals surfaces that are less reflective, meaning these surfaces are going to hold on to the light energy more and heat up. So that's like the ground or surface water. The ground is not reflective like ice is. So this reduces the Earth's albedo, which is the capacity to reflect light. So we talked about this when we talked about feedback loops a million years ago. So that is the ability of the Earth to reflect light. As the snow and ice melts, albedo goes down. And so what happens then is, as the albedo goes down, the Earth takes on that heat, warms up, which means there's more melting, which means that there is then less snow, which means the ability to hold onto heat is more, so it creates a really positive feedback loop. The loss of Arctic sea ice, so now we're back in at the North Pole, has led to the opening of new shipping lanes, and so basically boats can get where they couldn't go before because there was ice, and many countries are now fighting over the position to claim regions of the Arctic for oil and mineral extraction because those things are very valuable, and extracting more oil will lead to more climate change. Funny how that happens. And then also there's Arctic warming, and that is, again, North Pole, is thawing permafrost, and permafrost is permanently frozen ground. And so that causes the release of underground methane. So the ground is frozen, so any gases that are in there are also frozen, and there's methane down there. And as it thaws, the methane is released to the atmosphere, which then further intensifies warming because methane is a powerful greenhouse gas. And so it creates another positive feedback loop. As more methane is released, the Earth warms more, which means that more permafrost is melted. So we talked about rising sea levels, and these rising sea levels may affect hundreds of millions of people. Across the planet, sea levels have risen 24.1 centimeters in the past 135 years. So that's almost a foot, just shy of a foot. This leads to more beach erosion, coastal flooding, saltwater intrusion, and a greater impact by localized rises in sea level called storm surges. Storm surges are temporary and localized rise in sea level generated by a storm, and the higher the sea level is to begin with, the farther inland a storm surge can reach. And so this amount of rising represents a vertical change, but on most coasts, if you think about the beach, if water rises a foot, that's not a horizontal foot it moves. That could be many, many, many feet, meters, yards, whatever. It could go, if it's a flat, slow increase, a foot increase of water could travel very far and bring water to a large area of land. And along the U.S. coast, sea level is rising at varying rates. So in San Francisco, a 1 meter rise would cover the airport, Silicon Valley, all of that. The worst, it's most damaging in the Gulf of Mexico and in South Florida, most especially New Orleans. New Orleans, most of the city is already below sea level, and it's only protected by levees. And if the levees fail, like they did in Hurricane Katrina, which we'll also talk about, the city may be underwater.